Alright, today we are going to look on the concept of dilution by using dilution law. During dilution, we use the law of dilution, and this is very applicable in pharmaceutical sciences, especially when preparing solutions from stock solutions. As you know, a stock solution is a solution of known concentration, usually a higher concentration, from which the weaker ones may be prepared for convenience. Now let's check how applicable it is. We may have a stock solution of maybe potassium permanganate. As I said, the stock solution is a solution of known concentration and of higher concentration. So its concentration is known, but also it's higher. Now from this known higher concentration, weaker preparations may be prepared. Let's assume we have potassium permanganate 1:10,000. Now from this higher concentration, weaker concentrations such as 1:4,000, 1:5,000, potassium permanganate 5%, and the other solutions may be prepared. So each concentration has got its own use. For example, 1:4,000 potassium permanganate concentration is used as a gargle, also is used as a mouthwash. 1:5,000 is used for urethral and vaginal irrigations, and the other uses such as wound dressing and other several uses. So you can see that these weaker concentrations can be prepared from the higher concentration. So how do we do to drop the concentration from here to here? Then this is where we apply dilution law. There are several preparations which we can perform by using this principle. We can prepare cetrimide, hydrogen peroxide 6% or 3%. We have phenol. It can also be prepared by using this method. Several preparations with different concentrations may be prepared. So let's check some examples on how to do this. And all these calculations are very practical. They are so much practical. So our first question will be to calculate the volume of alcohol, 90% needed to prepare 400 ml of alcohol, 70%. Before we solve this question, we need to understand the law of dilution. What does it say? If it's a liquid preparation, we need to have concentration 1, volume 1, which means the initial concentration and the initial volumes. Then this will be equivalent, or these are proportional to concentration 2 and volume 2, or the final volumes. Now here is the magical scale. During dilution, we are struggling to drop the concentration. Always dilution affects the concentration. The concentration will change from higher to lower because we are going to add more diluent. Now, that is to say, the initial concentration shall be, the initial concentration, C1, shall be less than the final concentration because we are going to dilute this from higher to lower. While the vice versa is true, the initial volume will be less than the final volume. Why? The final volume will be higher because we are adding the diluent in volume 1. So if we add the diluent here, that is to say more volume will be produced, so volume 2 will be higher. At the same time, the concentration which was available initially will drop to the less concentration. This is when we are dealing with dilution. But when you are evaporating a substance, maybe you evaporate a certain fluid or a certain solution, something will happen. During evaporation, this was during dilution. During evaporation, the volume will decrease. So if we add volume 1, which is the initial volume, then volume 1 is less than volume 2. This is true, which means volume 2 is greater. In this sense, volume 2 is less than volume 1 because we have evaporated the diluent. But the concentration will increase. Concentration 2 will be greater than concentration 1. Hope you get that. Having known that, if we are dealing with semi-solid preparations, then the equation shall be C1Q1 representing quantity. This will be equivalent to C2Q2 representing quantity 2. Now let's solve the questions. So we are needed to calculate the volume of alcohol, 90% volume in volume, needed to prepare. So if it is needed to prepare, then we need volume 1. Volume 2 is 400 ml. We need to prepare volume 2, of which concentration 2 here will be 70% volume in volume, and volume 2 concentration 1 will be 90%. This simply means that in your laboratory you have alcohol 90%. Then you need to use 90% alcohol to prepare the second alcohol of somewhat a little bit concentration, 70%, with the total quantity of 400 ml. Now we don't know how much volume to draw from this 90% in order to, we don't know how much volume to add in 90% so as to drop the concentration. So from the proportion of dilution, C1V1 is equal to C2V2. So making V1 the subject, this is C2V2 over C1. So concentration 2, this is 70% times the volume 2, this is 400 ml divided by concentration 1, this is 90. So volume 1 will be, okay, 70 times 400. Volume 1 is 211. Volume 1 is 211.1 ml. So this is the amount of diluent which shall be added into alcohol 90% so as to drop the concentration to 70%. You can note that volume 1 is somehow less than volume 2, but concentration 1 also is less than, concentration 2 is less than concentration 1. Let's check another example. Okay, how many ml of formalin 2% will be prepared from 250 ml of formalin 36%? Remember, what you have on the table is what is considered as 1 or initial volume or concentration. What you need to prepare is what is considered as 2 or the final preparation. So in this sense, the question states how many ml of formalin will be prepared from. Then formalin 2% is what we are targeting to prepare. Then that is 2. So concentration 2, which is to be prepared, and volume 2, this is concentration 2, we have 2%, volume in volume. Then we need, then we don't know how much. Then concentration 1, this is 36%, volume in volume. Then we have volume 1, which is 250 ml. You can easily note here, if you have 2, then you have 36, automatically the higher is concentration 1. The one which is less is concentration 2. Volume 2, we are looking for it, and this volume 1 is available. Then solution. From the law of dilution, C1V1 is equivalent to C2V2. Looking for volume 2, make the subject C1V1 over C2, this is C1, 36% times V1, 350 over concentration 2, which is 2%. Then volume 2 is, we are expecting volume 2 to be higher than volume 1. This is 36 times 350 over 2, and this is 6,300. Okay, this is the kind of volume we are going to obtain after the preparation. Okay, let us check example number 3. Example number 3 utilizes somewhat a different concept. Here we have got more than a single dilution. The preparation is diluted more than once. It can be diluted twice or thrice. So if you meet such a problem, what do? Let's read this question. How many milliliters of a 17% weight in volume concentrate of benzalkonium chloride, this is a preservative, should be used in preparing 300 ml of stock solution, such that, be careful with the word such that, that indicates more than a single dilution, such that 15 ml diluted to 1 liter will yield 1:5,000 weight in volume solution. So this means that we should identify the number of milliliters of a 7% concentrate of benzalkonium chloride, which should be used in preparing 300 ml. So what are we preparing here? Preparation is 300 ml stock of benzalkonium chloride, such that okay, when 15 ml, which means 15 ml from here, if we draw 15 ml from here, then we dilute it. When we dilute it to 1 liter, this should give us a 1:5,000 weight in volume, but available in stock, available is 17% weight in volume stock of benzalkonium chloride. This question is so simple. In stock, you have 17%, and you need to know how many mils shall be required to be used to prepare 300 mils. And after preparing 300 mils of benzalkonium chloride concentrate, if we draw 15 mils from 300, then we dilute it to 1 liter, meaning we are going to add a diluent here. The final percentage strength, or the final ratio strength, is 1:4,000 weight in volume. So the first step to do, let us convert 1 liter into mils. 1 liter is equivalent to 1,000 mils. Then we may also do this. If the performance of dilution was done more than once, this means that the final percentage strength resulted from the previous, and the previous also did the same. So we may do it from the last step, going backwards, so that we may identify the initial concentration. So we may begin from here. If 1:5,000 weight in volume was the final concentration as a result of diluting to 1 liter, then what was the concentration in between? So 1:5,000, this is equivalent to, say, 1 gram is in 5,000 mils. Then what about 1,000 mils which were previously diluted? So if we happen to dilute here, this is what? 1,000 divided by 5,000. This is 0.2. Then this is 0.2 grams. So meaning that when 1 liter was obtained, in 1 liter there was 0.2 grams of benzalkonium chloride. Because 0.2 grams of benzalkonium chloride in 1 liter makes this proportion here. So, but also we also need to know what was in 15 mils. All right. So this 0.2 grams, before it was diluted to 1 liter, it means that it was in 15 mils, which is the previous volume. So if this was in 15 mils, then what about 300 mils? It contained how much? Okay, this is equivalent to 4 grams. So 4 grams was the amount of benzalkonium chloride in 300 mils. So if we really need to know the amount of milliliters to be used in preparing this stock solution, we need to go back to the available stock. The available stock was 17% benzalkonium chloride. 17% weight in volume means 17 grams of benzalkonium chloride were contained in 100 mils of water. So what about 4 grams? So 4 grams requires how much water? So this is 400 divided by 17. This is equivalent to 25 mils of water. So the amount of benzalkonium chloride which shall be drawn from this solution is 23.5 mils. Then this will be diluted in the manner shown. Okay, let's jump to the next example. Okay, there is this question about a certified red dye. How many milliliters of a 1% stock solution of a certified red dye should be used in preparing 4,000 mils of a mouthwash? That is to contain 1:20,000 weight in volume of a certified dye as a coloring agent. So we need, we don't know the initial volume to use, but the initial concentration is 1%. The final concentration is 1:20,000, and the final volume, we need to prepare 4,000 mils. So you can see we have two modalities of concentration, one in percentage strength and the another in ratio strength. So before we go any further step, let us convert this ratio strength into percentage strength. To convert ratio to percentage, 1:20,000 is equivalent to 1/20,000. Then how many are in 100 mils or 100%? Then this is 100 divided by 20,000. This is equivalent to 5 times 10 power negative 3. This is 5 times 10 power negative 3. So from the law of dilution, concentration 1 V1 equals to concentration 2 V2. If we need V1 there, that is C2 V2 over concentration 1. Concentration 2, that is 5 times 10 power negative 3 times volume 2, that is 4,000 over concentration 1, that is 1%. Then volume 1, that is 20 mils. All right, let's jump to the next example. These are the last two examples. If we want to have maybe a bonus of one. If a syrup containing, okay. If a syrup containing 65% volume, weight in volume of sucrose is evaporated to 85% of its volume, what is the percentage weight in volume will it contain? So look, here there is a change in the concept. We are moving from dilution to evaporation. Remember, during evaporation, the final concentration increases and the final volume decreases, which is contrary to the law of dilution. So let us see this. So the initial concentration 1 of this syrup was 65% weight in volume. Okay? And this one was evaporated to 85% of its volume. So what happened after it was evaporated to its 85% of its volume? Then what percentage weight in volume will it contain? Meaning that after evaporation, what is the final percentage strength? So after evaporation, what was the final percentage strength? So we really don't know what was volume 1 and what is volume 2. So from this concept, 65% weight in volume simply means 65 grams are in 100 mils. So that is to say, volume 1 is 100 mils of this syrup. Okay, then what about volume 2? The question says it was evaporated to 85% of its volume, meaning 85% of its volume, which means volume 2 here will be 85 mils. So what is required is concentration 2. From the law of dilution, concentration 1 V1 equals to concentration 2 V2, then C2 equals to C1 V1 over V2. So concentration 1, that is 65, times volume 1, which is 100, over volume 2, which is 85. Mind you, I told you that during evaporation, concentration 2 will increase and volume 2 will decrease. You can see volume 2 is 85 while volume 1 is 100 during evaporation. So concentration 2 is expected to be higher than 65. Let us see. That is 6500 divided by 85. That is 76.47. 76.47 percentage weight in volume. You can notice that concentration 2 is higher than concentration 1 because of evaporation. Okay, one more example. If 15 mils of a 0.06% atrovate nozzle were diluted with 6 mils of normal saline solution, what would be the final drug concentration? So which means in stock we add what? In stock we add 15 mils of a 0.06 atrovate nozzle spray. So volume 1 was 15 and concentration 1 was 0.06. Then this 15 mils was diluted with 6 mils to what? We don't know. So what is the final concentration? So taking into consideration the word with. So the word with indicates that there was an increase in concentration. So if 15 mils were diluted with 6 mils, then the final volume is 15 plus 6. At the end of dilution, we shall have 21 mils. Then that is volume 2. Okay? So if you know that, apply the same concept. C1 V1 is equivalent to C2 V2. Then what follows next? We need C2, make C2 the subject. This is equivalent to C1 V1 over V2. Then substitute concentration 1, which is 0.06, times volume 1, which is 15, over volume 2, which is 21 then you will get your answer. Okay, let's have one more last example. The last example on the concept of dilution will be on gargles. Now we have this concern here. When you are in the laboratory or in the hospital laboratory required to perform the following compounding of the prescription, look, we need to prepare 30 ml of potassium permanganate solution such that when a patient dilutes 2 teaspoonfuls of a solution with 4 teaspoonfuls of water will produce a potassium permanganate gargle. So our task is to prepare 30 ml, that is volume 1, of potassium permanganate gargle solution, potassium permanganate solution, such that, okay, when a patient dilutes 2 teaspoons with means plus 4 teaspoons, okay, what happens? We'll produce a potassium permanganate gargle. So you need to know the concentration of potassium permanganate gargle. That is 1:4,000. So that means this is concentration 2. Okay. So 1 teaspoonful is equivalent to 5 ml. So 2 teaspoons are equivalent to 10 ml and 4 are equivalent to 20 ml, making a total of 30 ml. Then that is volume 2. So we have volume 1, volume 2, and concentration 2. What is required here is concentration 1. Okay, the solution, concentration 1, V1 is equal to concentration 2, V2. So concentration 1, this means concentration 2, V2 over V1. Concentration 1, concentration 2 is 1:10,000. We can convert it to percentage strength. 1/4,000 is in how much? Of 100. So 100/4,000, this is 0.025. This is 0.025%. So 0.025% times volume 2, which is 30 over volume 1. Oh, okay. 210, 420, okay. So that is 30. Task, prepare. No. There was a mistake here. 30 ml is not volume 1. 30 ml is the total amount required. This is a total amount required to be prepared. Yes, prepare 30 ml of potassium permanganate solution such that when a patient dilutes 2, okay, so these 2 will be volume 1. This is volume 1. So here volume 1. Volume 1 is 10 ml. That was the initial volume and the final was the total of both. So, volume 2, this was 30 and volume 1 was 10. Okay, so concentration 1, that is 0.025 times 30 divided by 10, that is 0.075. That is 0.075 weight in volume. So that is the initial concentration. So how do you do this in your lab? This means 0.075 grams are in 100 mils of water. 0.075 grams of potassium permanganate are in 100 mils of water. So the initial concentration, potassium permanganate, this is the official formula, shall be 0.075 grams, and then you shall add water up to 100 mils. Then find the factor from the required. The factor is 30 mils divided by 100, which is the total. Then you will get 0.3. Then find the amount required. Thereafter, you dissolve this amount up to the required amount of water, that is 30 mils. All right, that is all about dilution, and now we shall be jumping to the other session, which is posology.